So Nanina sent an email asking me to make a video about this question. I've sketched it out here and I'm going to read it from her email. The question is, a pumpkin is thrown horizontally off of a building at a speed of 2.5 meters per second and travels a horizontal distance of 12 meters before hitting the ground. We can ignore air resistance. What is the pumpkin's vertical velocity when it hits the ground? So here's our building with its little happy windows. Here's our pumpkin. Our pumpkin gets thrown forward at 2.5 meters per second. We know that since we're not accounting for air resistance, that the pumpkin's still going forward at 2.5 meters per second as it's being pulled down by gravity until it hits the ground. So this is a little counterintuitive because we're accustomed to things having air resistance, right? But the fact is that in this problem, we don't have to account for it. So there's no acceleration going forward, nor is there any deceleration, right? It's going forward at 2.5 meters per second. It's still going forward at that rate when it gets down here. It travels 12 meters. The only vertical number we have right now is acceleration due to gravity. However, we have these two horizontal numbers, so we're going to work with that first. Let's see. Let's say that part one of this problem is going to be the horizontal part. Horizontal. So what do we know? We know that velocity initial is 2.5 meters per second. We also know, we just talked about this, that velocity final is 2.5 meters per second. We know that displacement is 12 meters. And we're trying to figure out what time is, right? We really don't need any of the equations that are on our sheet because we know that, I'm going to scoot this up a little bit, except the cat's sitting on it. There we go. We know that velocity equals distance divided by time, right? So in this case, we've got velocity, 2.5. Distance, we've got this, 12. Divided by time is what we're looking for. So we can multiply time over here. T times 2.5 equals 12. Divide this and we get time equals 4.8 seconds. Okay, so now we can try the second half of this problem, a vertical direction problem, and this should give us our answer. What do we know? In the vertical direction, we know that our initial velocity is 0. We know that our acceleration is, we're going to say 10 meters per second squared because that's quicker. We know that our time, which we figured out down here, is 4.8 seconds. And we're looking for our final velocity. So I'm going to look for an equation that has these elements in it. I'm going to choose this one. Velocity of the object equals velocity at time 0. I like to use velocity initial plus acceleration times time. This doesn't need to be moved around algebraically because it's already set to solve for velocity. So let's see. Velocity initial was 0. Again, remember we're talking in the vertical direction here. It was still in the vertical direction when it was first tossed off the roof. So velocity initial in that direction is 0. Let's see. Plus acceleration is 10. And we know that this is 4.8, right? The time is 4.8. V equals, we can disregard that because it's a 0. 10 times 4.8 is 448. So our velocity in the vertical direction when we hit the ground with our pumpkin is going to be 48 meters per second.